biggest scientific breakthrough of the century that opens a window onto the universe. Today, scientists announced they had detected gravitational waves after decades of searching. Physicists at Glasgow University played a key role in the discovery, which proves a theory put forward by Albert Einstein 100 years ago. Here's Alan Jenkins.
We have done something which is brand new.
The field has busted wide open.
It's monumental. It's like Galileo.
For centuries, we've gazed at the stars, wondering what's out there in space. Even with advanced technology, there's still plenty we're unsure about when it comes to the universe. Some of what we know comes from Albert Einstein. His theories of relativity helped us to understand black holes and the Big Bang. He's also described gravitational waves, ripples in space and time caused by violent cosmic explosions. But these have never been detected until now. Today, an announcement scientists across the world had been waiting for.
We have detected gravitational waves. We did it.
It's one of the biggest breakthroughs in modern physics, for the first time allowing scientists to measure mass in space. Scientists at Glasgow University have been instrumental in this discovery. This may just look like a piece of glass, but this precisely engineered glass fibre has been key in enabling this scientific breakthrough. That glass formed part of these massive machines called LIGO, which managed to find this phenomenon. It's a culmination of decades of work.
So I started my career in gravitational waves in the 1980s. So it's been my whole life has been going towards this point, to this first discovery, and not only to this first discovery, but into the future, because the discovery isn't the important thing, it's the fact that we have a new window on the universe. We can see the universe through gravity. Up till now, we've only seen the universe through light.
Scientists say it's a seismic shift in their approach to astronomy.
And you can actually hear them. So what LIGO has done, it's the first time the universe has spoken to us through gravitational waves. And this is remarkable. Up till now, we've been deaf to gravitational waves, but today we're able to hear them.
Einstein's predictions from the past have now been confirmed correct, with a new way of viewing the universe in future.
Well, joining us now is Professor Martin Hendry from Glasgow University, one of the scientists involved in the discovery, and in Edinburgh is the TV science presenter, Dr. Bunhead. Thank you both very much indeed for joining us. Professor Martin Hendry, first of all, incredible achievement. How does it feel to have been a part of this amazing discovery?
Well, very exciting. Of course, we became aware of this event back in September, so I've had some months to get used to the idea, but all of those initial feelings of excitement resurfaced again today, just seeing the huge amount of public interest in this all across the world. And
it's been described as opening a window onto the universe. What will this lead to?
Well, frankly, a little bit of it we don't know, because every time we've opened new windows before, like being able to use radio telescopes for the first time, or X-ray or gamma ray, we've always found things we never even knew existed before. But if we just restrict ourselves to the things we do know exist, we'll be able to probe them in a completely different way. We'll be able to understand things about the nature of neutron stars, very dense stars, about the size of Glasgow, but weighing the same as a star, weighing the same as the sun, very, very compact and dense. With light, you can learn a lot about them, but with gravitational waves, we can probe their internal structure. We can understand what's really going down deep inside. And of course, black holes, that's the event that was discovered today, two black holes merging. We can learn a lot about them as well.
Dr. Bunhead, as a fellow scientist, how excited are you about this announcement?
It's absolutely fantastic. I mean, it's real Doctor Who stuff that's going on here, and it allows us to really shift the way we think about the universe. You know, the universe isn't this rigid place we think it is. It really does stretch and bend in the ways that Einstein predicted it would, and that is just phenomenal. Mind-bending as well as space and time bending.
Give us an idea, Martin, of the scale of the project that's led to this. Many years in the making.
Yes, many decades in fact. So work on this began in Glasgow in the early 1970s. I was still in primary school then, but as we heard from my colleague Ken Strain, it's been going on for decades for many of us. And indeed, if you look across the world as a whole, there's more than 1,000 scientists within the LIGO collaboration. We're working also in partnership with another collaboration based in continental Europe, the Virgo collaboration. So many thousands of people that isn't just astrophysicists like me, it's people who are engineers, who are laser physicists, all sorts of different areas of technology have to come together to give us the kind of instruments that we need to make these very, very difficult measurements.
But the University of Glasgow had quite a pivotal role.
Well, it did indeed. So the reason we call this advanced LIGO is that it was upgraded to make it even more sensitive. Initial LIGO wasn't quite sensitive enough, or at least if nature had given us a black hole merger really close to us, but believe me, you don't want one too close to you, then initial LIGO may have detected something. But really with advanced LIGO, it was sensitive enough to make it a more or less sure thing. Okay, we didn't think we'd get one quite so soon, but yes, we did get one. And some of the key upgrades to make all of that possible were led by Glasgow University.
Fantastic. Dr. Bunhead, it's complicated stuff. I'm not going to pretend otherwise. I found it quite difficult to get my head around, but it has captured the public's imagination, hasn't it?
Yes, I'm not sure that the younger generations that I speak to will register a wibble of interest any larger than the tiny thing detected by LIGO. But in the...
Oh, and we seem to have lost Dr. Bunhead.
Oh, dear.
There we go, and he's back. Do carry on.
Hi. Oh, sorry. Where did you pick me up from? I was just saying, yes, I'm not sure that in the younger generations...
Oh, and we've lost him. What a
we can
shame.
detect gravitational waves halfway across the universe, and we can't even talk to
we can't even get the line to Edinburgh working. But maybe you could answer that question. Why do you think it's captured the public imagination so much?
Again, I don't want to introduce a note of disharmony here, but I would disagree. I think the younger generation are very keen on these ideas. We have colleagues in Australia who've actually put together a project to teach ideas about Einstein's view of the universe in primary school. I've also been involved a little bit in that for the Curriculum for Excellence. That's a topic for another occasion, perhaps. And we found that young people are very open to these weird and wonderful ideas. They're often inclined to blur the edges between where science fiction ends and real science begins.
And we've got Dr. Bunhead back. Fantastic. I really want to ask you a question. Where does this discovery stand in the pantheon of scientific discoveries, do you think?
Oh, we're in the red corner with Peter Higgs and the blue corner with Albert Einstein. I mean, together the pair of them are pointing towards the ultimate marriage that Einstein dreamt of finding a unified field of all the laws of nature. And this whole gravity wave depends on mass, and what Einstein didn't ask is where does mass come from, and Peter Higgs asked that very question. And so these two really go hand in glove together, and I wouldn't like to say which one is more important than the other. And as you know, said earlier, we don't know what's going to come out of these things for many, many years. So I really think it's a chicken and the egg question as to, but certainly up there with the Higgs boson. It's like when Galileo first looked out at the celestial bodies with his telescope and said, we are not the center of the universe, we circulate the sun. It's as massive as this and groundbreaking for our modern view of science. It's an enormous discovery.
An amazing, huge discovery, and you've been a part of it. I mean, that must make you feel incredibly proud. Is this the pinnacle of your career, do you think? Well,
I'd like to think there may be even greater achievements to come, who can say? But thus far, in terms of the scientific achievements of myself and the group and our university, it really does rank very highly.
So what next then?
Well, because this is the first discovery, we very much view it as the first chapter of a whole new book in astronomy. So as we heard from Edinburgh, we look to make further detections to learn new things about the universe. In fact, our advanced LIGO isn't even yet at its design sensitivity, what we were aiming for with all of those upgrades. It will take many more months before we're at that even more sensitive level, and that would surely mean, therefore, that there's lots more to be found. Very briefly from Dr. Bunhead, it opens up so many more possibilities, doesn't it?
Oh, it does indeed. And as Martin was saying, yes, the youngsters are interested when you point them that way. You do need to put it in front of them, but they're fascinated by space travel, and it does open up us looking back to, well, we're looking at the moment, I think 130 billion years ago for these two black holes having their little event horizons collide. So we've just got a whole new, as Martin says, chapter of science opening up to us. It's a very exciting time for science.
Exciting, and thank you both so much for sharing your enthusiasm for the subject. Thank you both for joining us this evening.